Okay, welcome once again to another INB382 demo demo video. And I'm just going to discuss here some of the projection capabilities or interfaces with Unity. So once again, we've got our friendly INB382 oil drum. Now we can see here that I have highlighted the camera in the top left-hand corner here, just like I did in the previous video. I'm going to focus on the projection components here. Now note, you've got a couple of ways to access this projective capability. It's also part of your viewer here. So if I click on this perspective ISO combination here, I can change the camera model in your modeling view. So this is an interesting application of it. So we can see here, this is the orthographic projection, and the camera, as you can see, all parallel lines that maintain their parallel direction, and therefore we have what is known as an orthographic projection. And as we can see here, there's no change in camera effects if we even move the camera backwards or forwards, which I demonstrated last week. It just stays the same. However, if we go across and change to a perspective view, and if I change my actual view back to a perspective view and set everything up nicely, we can see here now that our original view, I'll take this back because it'll be less confusing. So there's our orthographic view in our viewfinder here, but now it's in a perspective mode. So I'm going to go across and turn it to a perspective view for the actual camera in game. And as you can see, the camera preview down here shows up that the object gets a bit smaller. Why? Well, the whole idea is that foreshortening and distance effects are allowed inside the perspective projection. So we can see here that the camera is highlighted, and we've got what is known as our viewing frustum. It's a truncated pyramid with a front plane and a back plane and a field of view, which is more easy to see from here. There is an angle subtended between the normal going forward, the Z-axis for the camera, and the sides of the frustum. So these parameters are available to you in the interface here. So we can change the projection, orthographic, perspective. Okay, that's all cool. The next part is the near and far clipping planes. So at this stage, we've got the far clipping planes at 1,000. That determines how far away the back wall of the viewing frustum is. So if I can make it, say, 6, it's all very good. Nothing much changes. But know what happens if I make the far plane 3. Have a look down the camera preview. The object's disappeared. It's been clipped out. I can push the far plane back again to 6, and the object reappears. We can do that with the near clipping plane as well. We can push that forward. Now note, these are distances from the camera's location. It's not an absolute value. So from here, the front clipping plane is 3 units ahead, and the back clipping plane is 6 units ahead. So this means that we can play around with these with reference to the camera, and so that we know we have a finite volume for clipping. A couple of things to note: this introduces all sorts of issues around accuracy measures of distance. You want to have this volume as tightly around your scene as possible. And this will come up when we talk about Z buffering, and this will come up when we talk about shadow mapping. You need to do shadows for your assignment, so you need to be aware of how this volume is constructed. Moving on, we also have a field of view. So I think I can just quickly show you here that this is our 41-degree angle between the Z-axis here and the surrounding elements, the sides of the frustum. If we make that wider, as we can see, the frustum sort of expands out and the object gets smaller. which makes sense. You can see within the camera volume, it's less of the actual volume for the camera. So when it's projected, when it's done as a final projection transform, as we see in the lecture, it ends up being much smaller because the field of view is larger. And again, these are all sorts of effects you can play with, particularly if you're, say, doing gun effects. You're wanting to show a scoped view. You might narrow the field of view right down to show objects only with a narrow range, or you might want to show a wide view from, say, a tank commander's turret. You show a wide field of view at a wider angle. So these are the major components, and in the lecture we'll cover the theory and the matrix transforms to do this. Thank you.